In the earlier session, we tried to understand the work of the river and under what climatic conditions the fluvial process operates. River is an important agent of landform development. In this session, we are going to see the role of river in the process of evolution of various landforms. What are the various types of landforms evolved by the river? In this section, we are trying to see what are the major types of river landforms, what are erosional landforms, and how they are formed. Fluvial landforms created through the action of running water or streams. The fluvial landforms are of different type. They differ each other in terms of process of their formation. Fluvial landform can be either in the form of erosional features or depositional features. Two types of landforms, erosional and depositional, generally do not occur together. The rivers in their journey from the source to the mouth produce a variety of landforms. Generally, the entire course of the river can be divided into three sections: the upper course, the middle course, and the lower course. In its upper course, the velocity of the river is high and it has immense capacity to erode and transport the materials. Therefore, erosion is the major activity of the river in this part, and most of the landforms found in this section are erosional in nature. In the middle course of the river, there is a balance between rate of erosion and deposition. Landforms formed in this section are mostly depositional in nature. The erosional work is mostly in the form of bank erosion or lateral erosion. As the river reaches close to the sea, its velocity becomes very low and the river is not capable of any type of erosion. Due to the reduction in the velocity, it is unable to transport even the load present in it. Hence, deposition is the chief activity of the river in the lower part of its course, and most of the landforms found in this section are depositional. A variety of landforms are evolved by the action of river. These landforms are broadly classified into two broad categories as 1. Erosional landforms and 2. Depositional landforms. Rivers produce a variety of landforms through erosion of the surface over which they flow. The major landforms resulting from the fluvial erosion includes 1. V-shaped valleys, 2. waterfalls and rapids, 3. potholes, 4. plunge pools, 5. structural benches, 6. river terraces, 7. incised and entrenched meanders, 8. interlocking spurs, 9. river capture or stream piracy, and 10. peneplain and monadnocks. Now let us discuss about the V-shaped valleys. V-shaped valley are carved out by the rivers are significant erosional landforms. V-shaped valleys are formed in the initial or the youthful stage of the fluvial cycle of erosion. The V-shaped valleys are very deep and narrow. V-shaped valleys are the result of axial rate of down cutting or vertical erosion, which is responsible for valley deepening. V-shaped valleys will have steep valley side slope of convex element. Due to larger volume and greater velocity of water in the central part of the river channel, the erosional process is very active in this part of the channel. Due to greater erosion in the central part, the shape of the valley resembles the letter V. The steep valleys formed in the initial stage of the river due to the erosion are divided into two types. gorges and canyons. It is difficult to draw a line of difference between these two types of valleys. Gorges are formed due to active down-cutting or vertical erosion of the valley floor. The river during its youthful stage, the gorges are also formed due to the recession of the waterfalls. For example, 𝗪𝗏𝗃 gorge on 𝗧𝗦𝗔𝗧 river. Another favorable condition for the formation of gorges is the simultaneous uplift of the landform and downward cutting of the valley. Most of the Himalayan rivers are formed deep gorges. Indus Gorge is one of the deepest gorges in the world. The other gorges are associated with the Himalayan rivers are Satluj, Brahmaputra and Arun, etc. A canyon has marked similarity with gorges in that it has also steep slopes, narrow river bed and prominent vertical erosion. For example, the Grand Canyon of the Colorado River in the state of Arizona in USA. The Grand Canyon on the Colorado River is very deep, but its walls are not very steep or vertical because it passed through an arid zone. Waterfalls. Waterfalls are caused because of the sudden descent or abrupt break in the longitudinal profile of the river. When the river plunges almost vertically from the higher level to the lower level, it is called as a waterfall. A waterfall may be defined as the vertical drop of the enormous volume from a great height in the long profile of the river. A waterfall may be formed due to differential erosion by the stream. It happens when the rock along the path of the river are not of uniform hardness. If the rocks in the upper part of the course of the river are harder than the one in the lower part, the upper part is not eroded as rapidly as the lower part. When alternate hard and soft rocks are arranged in a vertical manner, soft rocks are eroded more rapidly than the hard resistant rocks and hence form scarps in the course of the river, which gives rise to waterfall of steep slope. Such waterfalls are called as vertical barrier fall. Great Fall on the Yellowstone River in the Yellowstone Park of USA is a typical example of vertical barrier fall. A series of rapids or small waterfalls occurring at a shorter distances from each other form cascades. Bhagavati Falls on the Krishna River in Raichur district of Karnataka is an example of cascade or step falls. Potholes. Potholes are the small depressions in the rocky bed of the river valleys are called as potholes, which usually cylindrical in shape. Pothole drilling is the mechanism through which the grinding tools like rock fragments, boulder, when caught in the water eddies, starts moving in a circular manner and grind and drill the rock beds of the valleys like drilling machine and thus form small holes which are usually enlarged. The diameter of the potholes ranges from few centimeters to several meters. Potholes are generally formed in the coarse grained rocks such as sandstones and granite. Pothole drilling is the effective mechanism of valley deepening. Plunge pools. Plunge pools are generally formed at the base of the waterfall. Due to the hydraulic action or thrust of the falling water and rock debris at the foot of the waterfall, a hole or a depression is formed. This depression is called as plunge hole. If the river forming the waterfall is seasonal in nature and it goes dry during some part of the year, such holes remain filled with water and they look like lakes. Such small lakes at the bottom of the waterfall are called as plunge pools. Many of the rivers in the Chota Nagpur highlands are associated with numerous potholes. Structural benches. If the soft and hard rock strata are arranged alternatively in a direction of longitudinal profile of the river, the differential erosion leads to lowering of the soft rock strata. Due to this, the hard rocks stay higher like benches, aligned longitudinally along the bed of the river. Such formations are known as structural benches. River terraces. River terraces are generally formed due to the erosion of former floodplains due to the rejuvenation caused by either upliftment of the land mass or fall in the sea level. River terraces are produced by vertical erosion by the stream into its own depositional floodplain. When the river reached the mature stage, vertical erosion or downcutting of the valley ceases. When the river are rejuvenated, the erosive capacity of the river increases substantially. Thus, the rejuvenated rivers deepen their valleys due to accelerated rate of vertical erosion. The river forms new narrow valleys within the valley and flat valley, and thus terraces are formed on both sides of the former valley. When the river is again rejuvenated, new narrow valleys are formed due to valley deepening. This process leads to the formation of second pair of terraces. The step-like development of the valley side slope is called as terraces. The narrow flat surface on either side of the river valley are called as terraces. Flat terraces are generally formed due to dissection of fluvial sediments of the floodplains deposited along the river floor. River terraces are classified as paired terraces and unpaired terraces. Paired terraces are formed due to rapid rate of vertical erosion resulting into the occurrence of terraces on both sides of the river, almost at the same level. Unpaired terraces are formed due to the non-concomitant vertical erosion or valley deepening and lateral erosion. Movement of the river channel. Most of the Himalayan rivers have one set of terraces. This indicates that these rivers have experienced rejuvenation more than once. The river terraces may also result due to the receding of water after the peak flow or change in the hydrological regime due to climatic changes. Incise and entrench meanders. River meanders refers to the bends of the longitudinal courses of the river. River meanders are common in the floodplains. Meandering of the river is associated with the second or the mature stage of the river. Because of the lateral erosion, stream flowing over the gentle slope develops sinus or meandering courses. The river meandering takes place when the stream gradient is very gentle. Sometimes the river cuts meanders within the already existing meanders. That is, vertical erosion or downcutting is associated within the meandering channel instead of lateral erosion. In such cases, the meandering river channel becomes deeper with side slopes of the meanders become steeper. Thus, very steep and wide meanders can also be formed to cut hard rocks. Deep cut meanders with steep walls are called as incise or entrenched meanders. Incise meanders are mostly formed due to the upliftment of the area or rejuvenation. Due to upliftment, the stream gradient increases and therefore the river undertakes vertical erosion within the meandering river channel. Thus, meanders are associated and developed by lateral erosion, whereas incise meanders are developed by vertical erosion or valley deepening. Interlocking spurs are generally associated with the meandering river. The meandering river undertakes erosion on one side of the river and deposition on the other side. The meandering river which undertakes erosion on one side of the river develops concave slope, whereas convex slope is developed along the side of the river where deposition takes place. When the course of the river is neither plain nor made up of rocks of similar resistance, the stream therefore cannot flow in a straight line. In such conditions, the river develops loops or bends in the course of the stream. The winding course of the river or the zigzag flow of the river is called as meandering of the river. In meandering river, the bends in the river becomes more pronounced because the water on the outside of the bend flows more quickly and it therefore erodes very strongly on this side. The stream undertakes undercutting as the process of erosion develops concave steep slope on one side of the stream. The slope on the other side of the stream are very steep and are known as escarpments slopes. On the other hand, when the stream flows with a slow speed, other side undertakes more deposition than erosion and therefore develops convex gentler slope known as slip of slope. Under these conditions, projection of highline develops and these projections of highlines are called as spurs. When the spurs from both sides close each other, they are known as interlocking spurs. River capture or stream piracy. The phenomena of river capture is a result of differential erosion by neighboring streams originating on the either sides of the water divide. It is often associated with the headward erosion. If one of the streams has larger volume or flow over the steeper slope than the another, it will deepen its channel to a lower level than that of the other river. It may be simultaneously lengthens its valley by cutting backwards across the water divide. In such a situation, the water flowing formerly into another river will start flowing or diverted into this stream, and the other stream thus may be left dry, which is called as misfit stream. Valleys of captured streams having no flow in them are called as dry valleys. This phenomena is called as river capture or stream piracy. Peneplains. Peneplain is an erosional plain formed by the action of the river. A peneplain is formed towards the end of the cycle of erosion. It is an extensive area which is more or less a flat surface. Peneplain represents low featureless plain having undulating surface with scattered isolated low conical residual hills. The low conical hills are called as monadnocks. They are the remains of hard resistant rocks that have survived the erosion. Most of the landscape is at or slightly above the sea level. The whole surface approaches closer to the sea level or the base level. The end product of normal or fluvial cycle of erosion is termed as peneplain by W.M. Davis. Among the various geomorphic agents, river is an important agent of landform development. A variety of landforms are developed due to the work of the river, which are both erosional and depositional in nature. The landforms carved out by the action of river are called as fluvial landforms. Even though erosional landforms are evolved by the vertical erosion, lateral erosion as well as headward erosion. The role of vertical erosion is very significant in the landform development. The erosional features like gorges and canyons, waterfalls, plunge pools, potholes, structural benches, river terraces, incised meanders, river capture, peneplains are the major erosional landforms. In the next session, we will be dealing with the depositional landforms.